So first of all, good afternoon, everyone, and welcome to the seventh webinar, to this webinar series of Emeralds project. Today, we talked about, we will talk about urban dynamics and decision support, risk assessment, and forecasting for public events. We are here with another use case that worked in this projects along these 3 years that are coming to an end in 6 months. So we are here for 1 hour today, and this is Maria Letizia Mari from Trust IT Services, the communication dissemination leader in the project, and here with me, Sara from Trust IT as well, Sara Bozzi. And the session will be opened by Konstantinos Dafloukas from Inlecom, who is the project coordinator of Emeralds. After that will be the turn of Sasha Hogendorn-Lanzer from TU Delft, who is the work package leader of the use cases, of the 3 use cases that we have in our project. Then we will give the floor to Jeroen Steenbakkers from Argaleo, use case leader. And he will talk about the Hague as a testing ground. So the Hague as a use case and a testing ground for our project. We will conclude with the Q&A session and the panel discussion with the questions that we will get during the webinar. Just a few tips. The questions are kept in the Q&A session, so please write there your questions along the webinar if you have, and the panelists, we will reply to you at the end of the webinar. The webinar is recorded and will be shared on the YouTube channel and on the website. And the slides will be shared as well after the webinar. So now I want to give the floor to Konstantinos, project coordinator of Emeralds. Konstantinos, the floor is yours.
Yes. Hello, everyone. Thank you for joining this event. And of course, I would like to thank Maria Letizia and Sara from Trust IT for organizing this event. Today, we have our first use case in Emeralds projects where Jeroen and Sasha will provide some insights of the use case, how Emeralds contributes to the so-called mobility sector. Let me share my screen. So my name is Dafloukas Konstantinos, and I'm the project manager of Emeralds project, and I'm representing Inlecom Innovation, the project coordinator. So a few words about Emeralds project. The project started in January 2023 and ends in December 25. It's a reaction, and it consists of several partners from industry and academia. And the most important, the partners are located in different countries across Europe that increase the cross sector and cross-border cooperation for Emeralds project for the mobility sector. So what the Emeralds vision about? The Emeralds vision is to design and develop an urban data-oriented mobility analytics as a service, the so-called MAS toolset, that is consisted of the so-called Emerald services. The latter is combined in a proof of concept prototype capable of exploiting the potential of extreme urban mobility data. This toolset, the scope of this toolset is to enable stakeholders in transport sector and mobility sector to collect and manage data that could be described as data of high volume, high velocity, and high variety, and analyze them in online and offline settings. The toolset will offer advanced capabilities in data mining and will be validated in the 3 pilots. Today we have use case number 1. So about the use case number 1, it's related with the risk assessment, prediction, and forecasting in crowded events. The whole scope of this use case was to design a risk assessment, prediction, and forecasting toolkit, for conditions and circumstances in events by exploiting data of extreme scale and by leveraging the impact of AI analytics. One of the final steps of this use case is to assess and identify the additional data sources needed to enhance the performance and the overall analysis of the broader deployment and business. But I will leave the floor now to Jeroen.
No, I think you're going to leave it to me first.
No, sorry, Sasa. Yes, sorry.
No problem.
Yeah.
Okay, thank you. Thank you very much, Konstantinos. Yes, so now is the session from Sasha Ogendorlancer, and she will present the umbrella framework of the use cases. Sasha, the floor is yours. Thank you.
Can you all see my slides?
Yeah, perfectly.
Yes. Okay, perfect. The second use case that we're talking about this week, we had a nice one. Please look at the Emerald's website, I think, to look back at the meeting that we had on Tuesday on the second use case about traffic management in Rotterdam. My name is Sasha Hogendoorn. I work for the Mobility Innovation Center as director. It's part of the Delft University of Technology, and my aim is to set up projects that look at innovations between, on the one hand, enthusiastic researchers, local and regional governments, as well as companies, looking for a mobility system that is future-proof, is sustainable, inclusive, and all these kinds of things. Emeralds of data and AI play an important role in these types of projects. And that's one of the reasons that we are part of the, I think, a very nice Emeralds consortium. Today we're talking about risk assessment and forecasting for public events. We specifically focus on Scheveningen. I'll tell you a bit more about that in a second. But first of all, what are we doing? Marie-Laetitia just mentioned I'm in charge of Work Package 5. In Work Package 5, we want to investigate and assess in which way all of the nice Emeralds, extreme scale data acquisition, processing, management, analytics, and visualization tools that we're developing can be applied to real-world problems. How can we make them applicable, and what is the potential, not just for the location that we're looking at, but also the scale up of that. We have 3 use cases, all within the field of urban mobility, and we selected them in such a case that we can demonstrate the wide range of different Emeralds that are developed within the projects. So the functionalities, the project is called Emeralds, but all of the different functionalities that we develop are also called Emeralds. And what we hope to do in these 3 use cases is also to show potential stakeholders how these Emeralds, these functionalities can be important in their own daily work, and also in such a way that they can be used also in the future. When we selected the 3 use cases, we did it in such a way that these use cases differ in terms of their time scale, the geological scale, the data types that are used, the availability of data, like I said, the type of application. So are we going to use the emeralds to estimate, for example, the current situation in the network? Are we going to predict? Are we going to do policy analysis? You will see them pass by, all 3 of them, in the upcoming slides. At what time horizon are we looking at? Let's go to the use cases. Jeroen is about to present about our beautiful beach area in The Hague. It's called Scheveningen, where on a yearly basis, millions and millions of people come to visit and enjoy the nice weather and the seawater. What you want to do is that you want to manage the large amount of crowds that are not just on the beach, but on the boulevard, the amount of cars coming to parking garages, the amount of people using bikes, rented bikes or shared mobility, public transportation to reach the area in such a way that there are no risks and everything can go as smoothly as possible. The second one, the one that we talked on Tuesday, it's not just about one modality, crowds, but we're looking at the full network of Rotterdam and all of the different types of modes that are using partly the same infrastructure within the network. So we're looking at car traffic, we're looking at bikes, we're looking at public transportation, and we try to avoid, for example, congestion, to give priority to public transportation, prioritization of cyclists for the full city. The last one mainly focuses on policy, so not on the operational side, but more on policy, and it focuses on public transportation. So in the city of Riga that we're going to visit as consortium next week, we're looking at public transport, trip characteristics, environments, and traffic flow data analytics. So hopefully we can see and discuss with the partners there how the emeralds are going to be used in the upcoming years. Where are we in the project? We started January 2023. We're in the last part of a project, and I have to say it's at this point pretty busy for the use cases, going towards implementation, as well as writing the assessment reports that will be available at the second half of this year. And hopefully you can learn a lot about them, of how to implement and apply the different emeralds. For the assessment, what are we looking at? On the one hand, and that's done by the technical partners, they're looking how their software performs during calibration of their models, but also with respect to speed, to the amount of storage capacity, energy the systems use. What we as use cases are going to look into is which specific software performance KPIs we can get. For example, which percentage of crowd size is predicted correctly? Is a peak predicted at the right time? For just as an example, Jeroen will show some more practical examples later on. Of course, you see it on the lower downside on the right. We're also looking what impact we make, with whom we discuss our results, scientific publications, webinars, press releases, and these kinds of things. And I think from a use case perspective, I think the most important one, what is really the impact that we can make on these pilot or use case locations? So what can we save in terms of costs? Can we save lives? Although that's a very difficult one to assess in practice, but also things like reduction in carbon emissions. If I look at the Rotterdam use case, is there improvement in the usage of public transport? If I look at the city of Riga, so these are the different elements that we're going to take into account in our overall assessment reports. Quickly, how we take our approach. we have within the project a lot of different data sources that we can use. Using the emeralds that we have developed, we can transform these data, combine these data sources to come up with information. For example, by fusing data to come up with good estimates of the situation in the network. If you look at Scheveningen, we can come up with predictions and forecasts with risk assessments. Based on that type of information, we can define certain actions, how to manage or control our traffic, how to make planning decisions, how to implement decision support. And given these actions, in the end, we have a real impact on the different cities that we're working in. So there we really have, for example, improvements in the multimodal traffic operations, improved safety by better decision making, cost reductions to a more adequate deployment of personnel. I said 2 slides ago, but just as a short wrap up, what are the main elements that we as use case partners take up when it comes to our assessment? Like I said, we have the use case specific software performance assessment, and that means we verify in which respect the functionalities of the emeralds are in line with the objectives that we have in the use case. And we validate as much as possible the, for example, the predictions, the forecasts coming out of our emeralds against the ground truth that we have available. And at the same time, we're looking at our business performance assessment. And that means that we want to see what's really the benefit, not just for one stakeholder, the city, or the police in our case in Scheveningen, but for many more stakeholders, the public, shop owners, everybody who's in one way or the other related to one of our use case locations. I have to say, this is like Konstantinos mentioned in the beginning. It's a research and innovation action. It's not an innovation action, which means in practice that we don't have to implement all of the elements within the real business. That means that for some of the emeralds, we won't be able to really see in practice how they function or what their impact is. And in that case, we will try and use, for example, interviews, guided questionnaires to get an idea about the business performance. And we have scheduled these interviews in August, for example, for Scheveningen, since that's the period that is going to be the busiest there. And that is the time in which the tools that we're developing are for them the most relevant ones. I want to stop my story here because I know Jeroen has prepared many slides with a lot of results, but also a very nice demo. So Jeroen, I'm going to give the floor to you.
Yes, thank you.
Yeah,
Sure.
so thank you, Sasha. Just to say thank you. The floor is okay, and the slides are okay, they're perfect. Go ahead, Jeroen Steenbakker.
So everybody sees my screen now, yeah? So welcome, my name is Jeroen Steenbakkers from the company Argaleo. We are a company from the Netherlands which develops digital twin solutions, and we're happy to be involved in the Emeralds project to learn from each other. Today I will talk to you a little bit about the Scheveningen The Hague case and how we've implemented some of the Emeralds to support and also test the results in real life. Well, to give you a brief introduction about Scheveningen, Scheveningen is, let's say, the most busiest beach of the Netherlands. It's located near The Hague, probably a city which you know, and approximately every year 15 million people visit Scheveningen. So actually means that every inhabitant of the Netherlands once a year, more or less, goes to Scheveningen. So that's a pretty high amount of people going to Scheveningen. And on the other hand, as you can imagine, it is close to the beach, and there's only one way to go to Scheveningen. So there's a lot of mobility and crowd management issues there. We have parking garages, there's traffic, and also, yeah, in the last years there have been some incidents on the beach, which also really created the urgency for better insights in the crowdedness in and around the beach. We're working very closely together with the City of The Hague, so that is the municipality, but also the police is involved. So we work very closely with, let's say, all the local authorities who eventually will use our data and predictions and information to further align and use that information to eventually make real life decisions and eventually, hopefully, create a safer environment and a better working environment. Well, what's important here, we have a digital twin platform which is actually already used by the city, and in which a lot of basic data is connected. I will show you a live demonstration. And what's very appealing about this project is that together with the Emeralds team, we use that historical data that we have. We use the data which we knew and turn them into variable predictions. Because actually, what you would like to know is that, okay, will it be crowded in a few hours instead of seeing, okay, it's crowded now. And that's more or less the background of the situation. To give you some more insights, in general, there are, so we're talking about forecasting. Yeah? So we're talking about forecasting of visitor numbers. We're talking about forecasting of number of cars which we can expect, and also forecasting based on weather, as you can imagine. I'll give you some more information about that. But there's actually two types of forecast. The first one is more tactical. So you have to imagine that looking at, let's say, on a Monday or Tuesday, the team starts to plan the number of people they expect to need to eventually ensure that the beach is safe. And that planning is done, let's say, 7 days ahead. So on the one hand, they would like to know on a Monday, Tuesday, how the upcoming weekend will look, because then they still have enough time to make schedules and also, and also make sure that they plan the right people at the right place. A second is a more sort of more real-time planning, and that's more operational planning, and that's on the day. So you have to imagine that on a Saturday morning, 10 o'clock, if they expect the weather to be more nice than expected, they still have some options to sort of scale up the amount of people, and also scale up the scenario they would like to apply. And for these purposes, it's very useful to have an 8-hour short-term prediction. So we're actually focusing on two types of prediction. One is a short-term prediction, and the other one is more mid-term, 10 days ahead prediction, using all kinds of data which we have available. This actually shows here. So it's forecast horizon. Maybe good to know that looking at the mid-term forecasting of 10 days, it's also very important that we have a 3-year history. So to give you a brief explanation, so of course you can imagine that the weather is very important, but also national holidays and also specific events. So part of the prediction is also an event calendar. So upcoming Saturday, we say, okay, it's Saturday, it is a holiday season, and there's a specific event, there's a dancing event on the beach, and giving this information, we expect that it will be this and this crowded. And this is what's included in the midterm forecasting. If you look at short-term forecasting, we use more real-time information about current parking garage information, also information about, okay, will it potentially start to rain in a few hours? So this all gives information to really make, let's say, quick time decisions a couple of hours ahead. Also to sort of still do operational adjustments. Well, this is more the technical picture, also connecting, let's say, the emeralds which were developed by the team to our, let's say, data dashboarding. On the one hand, we provide a lot of historical data, information about weather information, event calendars, holiday calendars. We do visitor monitoring on the beach, and we have a lot of parking data. And what we also do is that we also have a sort of a streaming data platform. So there's a lot of data coming in, and every day we have new measurements. So we have a sort of a streaming data platform, and every day we do new measurements, and let's say the historical database grows. And this also what makes it extreme scaled, because we are dealing with a lot of large data sets. Then in the middle, as you can see, so this data is then processed by one of the emeralds, and also observed, and then based on different forecasting models, So in this case, we created a couple of forecasting models, but the most important ones are the parking occupancy. So we predict how much cars we expect in different parking garages. So next to the amount of people on the beach, also, let's say the number of cars in the parking garages, which also reflects on maybe traffic jams in and around the beach. It's very important because there are only a couple of roads, and once, let's say, too much parking garages are full, people cannot go back, and you have a sort of a deadlock in the traffic system, and therefore having proper traffic adjustments is very important. Secondly, we do this crowd density prediction, so we predict how much people more or less will come to the beach, and those two are very important indicators to eventually determine how much people you need, how much traffic engineers you need, how much police force you need, and also how you can potentially better spread the crowdedness on the beach. And what's very interesting is that we directly connected these emeralds in a sort of API, so it's a direct technical connection to our dashboarding, and I will give you a presentation to also test the working. But since we connected it to our dashboard visualization, we can also offer it in a very user-friendly way to, let's say, the people in Scheveningen and The Hague to also test this data and also use the data in a more user-friendly way and also a scalable way. And as the summer season in the Netherlands is currently starting, they are now also starting to use this dashboard to also eventually, as Sasha described, measure the performance of the forecasters, and also eventually measure what is the business case and how they use this data to improve not only the safety, but also maybe economic development and other purposes. So this is a very exciting time for us, because at this point, we really start to test the emeralds in the field, in real life, and hopefully it will really help, let's say, the people who are responsible for safety on the beach to get a better understanding on the crowdedness, etc. So this is what I also told. There are actually two. So from a technical perspective, there are two pipelines. There's a more technical pipeline and operational pipeline, and the accuracy metrics. So for the academics under us, we are eventually, what's very important also to measure the performance of the system, actually keeping it simple. Eventually, we also save the forecasts, and a couple of days later, we sort of compare this to the real figures to also give a sort of confidence level, also to measure the performance of the forecast, and this we can then also use to improve the forecast. And this is what is, and in order to test the confidence levels and test the reliability of the forecast, we use these accuracy metrics, which are named on the right of the sheet. Coming back, to make it a little bit more simple, I would like to explain to you a little bit how Scheveningen works with different risk scenarios, because actually you can imagine that given a certain crowdedness, there's a lot of intervention set into place. And in order to make this simple, they created, let's say, 4 crowdedness scenarios, which they use to eventually kick off some of the interventions they would like to do. And an intervention can be, okay, we need to start communicating via social media. Another intervention can be, okay, we need to close down the road. Or another intervention can be, okay, we need to close down the parking garage because it will be too crowded. And the biggest intervention is that they say, okay, guys, the beach is full, you cannot come to the beach anymore. And in sometimes a year this happens because it's really too crowded, and this is also the red scenario. So actually what we're doing, on the one hand, we have, let's say, more quantitative results on crowdedness levels and parking garage levels, etc., but eventually we would like to know, and this is also something we're working about, and I will show you a brief explanation about, okay, actually what you would like to predict is saying, okay, upcoming Saturday we expect that we will have an orange scenario, and it will be yellow, and it might be the case that at 2 o'clock when there's a peak, you will go into an orange scenario. And if we can predict it in this way, we sort of have a risk scenario prediction, then we will really help the team do a much better planning on what to expect, because now they do it based on experience, and they have a lot of experience. So now they do it based on experience, but it will really help them to have, let's say, quantitative measures, and also measures which sort of approve their idea, which really helps them to make better decisions on all the interventions which they are planning to do. You can imagine that on the one hand, if you have too less intervention and it gets too crowded, you have an issue. But the other way around, if you have too much intervention, it can be more expensive than actually needed. So there's also an economic perspective on this. Well, now I will give you a live demonstration on the current dashboard, which we already have running with some of the emeralds connected. So I will switch screens. So give me 2 seconds. What you see here, so this is the digital twin of the beach area. Yeah. So to give you a brief explanation, so we have here the beach, and this is a boulevard, but on the long stretch there's a lot of space to also lie on the beach, etc. But as you can see, there are only a couple roads to go from and through the beach. So it's very important that that you can not only come to the beach, but also more importantly, that you can also go away. Because if you can imagine, if it starts to rain, people want to leave as soon as possible. And it's very important that if people want to leave, that they are not stuck while they want to leave. So it's not only about coming, it's also about going. To give you some idea on, let's say, the current information which we have available, you can see that we have a sort of we have weather information real-time available. So we have the current weather, we have the weather of the upcoming hours, and we have the weather of the upcoming days. Some other real-time information which we have available is, let's say, all the public transport flows which are set in place. There are no train stations, but in the Netherlands we have trams, and here you see the live position of all the trams moving around. Another important data source is the traffic information. So what you can see already, coincidentally, or maybe not coincidentally, because it's Friday and the weather is nice. So at this point in time, probably a lot of people go to the beach, that the roads to the beach are already getting full. So it's very important to measure this information from real-time information. Another data source which we have is shared mobility. So here you see that there's a lot of shared mobility scooters used also to go to and from the beach. So not only parking of cars in garages is important, but also parking of all shared mobilities, scooters and bicycles is a very important key indicator to determine the crowdedness. And in order to measure, let's say, the crowdedness on the beach, we have multiple sources, but a very important source is that we have information about let's say, the current crowdedness. So this actually says the amount of people which are currently there in relation to the maximum amount and also to the normal amount. So what you see here is that we have an actual measurement on, let's say, the crowdedness on different zones in the beach. So this is all real-time information. And looking back, you see that since we also historically store all this information, we also have information about the historical use. So here you see, for instance, if you look at this specific part of the boulevard, we can see that in the last 30 days, specifically on the Saturday, there were a lot of people. But this also shows that we have a lot of historical information available to also, let's say, monitor if certain interventions were helpful, yes or no, if the crowdedness was spread in the right way. But it shows how currently they are already using it for real-time information and historical information. And now we are going to move over to the connection to the emeralds, because here you see this is a menu item. It's in Dutch, you probably can't read it, but you have to trust me. So it says voorspelling, which actually means prediction. And here you see that we now connected the API of the emeralds directly to the dashboard. And when I press the button here, you will see that I will get a prediction for the upcoming 6 days of Scheveningen. So here you see that on this is a Saturday, we expect 2 peaks, one around 2 and one around 5, which is actually normal because there's a sort of a lunch peak and a dinner peak. You see here that on Tuesday, we expect it to be a little bit more crowded, and probably it has to do with the weather. We know upcoming week it will be very hot in the Netherlands. So there you see we can expect a lot of people to go to the beach. So here you see that we have the direct forecast connected of the visitors. We can do the same with the parking garages. So here you see that we have 3 important parking garages, which are from which we also have forecasts available. So here you will see, if I connect them to each other, you will see that we will give a sort of also a 7-day forecast ahead in order to show how crowded these parking garages are. Well, probably at this point in time, it doesn't really say a lot, because it only says numbers, and of course the crowd manager knows what these numbers mean. But what's important, and now I move over to the presentation again. Give me 2 seconds. So here you will see. So this is a sort of a dashboard which we are currently creating, and this actually puts all the information together. So the parking garage predictions together with the visitor predictions, and then also connect them to the different scenarios. So what you see here, if you look at upcoming Sunday, we expect to go into the orange scenario around, let's say 12 o'clock. So this is really useful information, because upcoming 7 days ahead, we can say, okay, probably on Sunday we do not have we will stay in the green scenario, but upcoming Saturday the probability of it going orange is so, and this is actually in one view. We create a very good risk scenario analysis, saying, okay, you can expect to need these interventions in the upcoming days. And this is a mock-up scenario, but next week we will also have this available for the team, and then upcoming summer they will also use this. Okay, so that's what we currently developed. On the side, we're also already looking into different KPIs and the technical results. So we are now measuring the performance of the person count predictions for each of the areas. So we are really measuring, as I told you, the predictions together with the ground truth to see what the reliability is. But more importantly, we're also connecting the different threshold scenarios in order to determine if we really give good advice, right? And so we are very closely working with the cloud manager on Scheveningen, and every week we have a meeting in which he tells us, okay, guys, at this point, for instance, this weekend you did a very good prediction, but we saw that at 2 o'clock it was still orange while you were predicting purple, for instance, and this is how we then also optimize the system, but also do a sort of a qualitative assessment on all the different, let's say, interventions which were put into place based on our predictions. And here you see more the business KPIs, right? So we have a lot of technical KPIs which we can really measure, but there are also some other stuff, some other KPIs more from a business perspective, which are not directly measurable, but eventually via interviews and via talks to different local stakeholders, we will try to give a very good explanation about the business KPI. So you can imagine that, for instance, staffing is very important. So if based on proper prediction, they can do a better planned staffing, eventually it also has an economic perspective. We will try to understand if there's a good relation between, on the one hand, all the interventions which were put into place together with the predictions which we did. We will try also talk to the local police, saying, okay, since you use this information, did you have better information, or would you otherwise have done it otherwise, etc., etc. Furthermore, there's also a pretty big economic perspective, because Scheveningen has a lot of restaurants, has a lot of bars, has a lot of shops, and eventually, if we can make sure that the people are spread out more evenly, probably there's also a higher economic development, because people can go to all the restaurants, for instance, right? So these are all types of, this information is hard to get, because the restaurants will not share their revenues with us, but, you know, talking to local people, we will try to understand what, let's say, the business part of a better understanding of the crowdedness will be for the beach, to eventually measure how the emeralds helped us here. So this is actually what I already talked to you about. So we will talk. So actually, we sort of measure the system. We sort of measure the results from different perspectives, from a technological perspective, operational perspective, governance perspective, and also the residents. So also from what were eventually the benefits of a better spread, of a lower risk levels for the residents. Looking ahead, upcoming summer we will do a lot of testing. We are already started with technical KPIs, with the technical measurements, but this summer is very important. It's very exciting to learn how it helped us, and eventually after summer we will sort of finalize the project. We will also report the project, and then, which is very important because this is still low TRL or lower TRL level testing phase, but yeah, probably the chances are pretty big that the municipality will say we would like to use this structurally more often, maybe also in other locations. So then we really need to talk about the governance, really putting it into place, and also integrating it with more, let's say, the municipal operations for a better perspective. At this point, we're really looking at it from a pilot perspective, but if it's eventually going to be used, we really need to connect it to the, let's say, the more organizational processes of the municipality. Well, to summarize, at this point, Emeralds already proves the value because we have a good prediction of crowd analytics and parking analytics. It's already very useful to see how crowded it will be, and we already know that from a technical perspective, we have a high reliability of forecast. Real-world testing will confirm the impact, so that's what we'll learn in the upcoming months. And eventually, the success will also depend on I mean, this is really a technical project, but in the end, it's also about governmental bodies using technology. So now we will focus on the technical success, but once it will be successful from a technical perspective, we really need to talk about embedding it in the municipal structures. And that's also a different type of challenge, but it's definitely a challenge. So thank you. If you have any questions, feel free to ask them, and probably Maria will take over now, right?
Yeah. So first of all, I want to thank you for the demonstration, and also the your presentation of all the aspects that you covered for this use case, which is quite interesting actually. And we got some questions. So there are different aspects, I may say, that are attracting the attention, because there is a pure risk assessment intervention, related intervention aspects, and some more under the municipal perspective. So I start with one, which is pretty simple, actually, the question, but I don't know if it's from you, it's important at this stage, but it says, how do you differentiate between normal crowd dynamics and potential risk scenarios, especially during political sensitive demonstrations? So it means, the normal crowd dynamics probably related to, I assume that they're referring to the one that you already showed in summer, or in that case.
Well, that's a good question. Some answers there. First thing is that we are actually lucky that Scheveningen is a sort of a recreational area, so people go there to have a nice time. If they are so in The Hague is a very high political level. I mean, we saw that last week. We all know. I mean, we received the whole world in The Hague, and also there were a lot of more, let's say, political, how do you call them? Sociaal even. So there were people gathering against the politics, but that will happen in other locations, not on Scheveningen. So we are lucky. But also that also meant that we were not able to really create a proper connection between crowdedness and the political behavior. So people go to Scheveningen to have a nice time. Nevertheless, there's a lot of young people. Risks are very high, and what we noticed is that as long as people are moving, as long as everything goes well, the chances of incidents are very low. But there's a very small level, there's a very small threshold level. So you can imagine if the parking garage is full and you need to stay in your car, and it's 30 degrees outside, while you actually want to go on the beach, then people get excited. And then there's always this level, maybe good to tell a little bit about the decision-making process, is that actually the municipality is responsible for the normal operations. But once an incident gets to, let's say, high risk, the police will take over, right? So actually, the police, so as long as it goes well, the police does not need to be involved, right? But there's a thin line between crowdedness and then moving into incidents, because a couple of incidents can happen once it gets too crowded. But it's at this point, really measuring it from a political perspective is still difficult, because there's not a lot of political activity on Scheveningen.
Yeah, and this is actually the topic that probably is opening to a different level of, let's say, a question, which is very much related to this one. And the question is, given the unique characteristic of The Hague, how transferable is this approach to other European cities with different growth dynamics? That's more or less the point that you already covered.
No, that's so. It's I think it's very scalable. To be honest, we are already doing this on other beach areas in the Netherlands. There we have a sort of a 10 different. So we, as you might know, we are connected to the ocean with the half of our country, and this means we have approximately 10 to 15 cities who are connected to the beach. Scheveningen is the biggest, but we have more or less 10 who you probably know Zandvoort from Formula 1 races. There's also a pretty big area there. So what we did here is more or less directly reusable on, let's say, the beach areas, because they all have the same aspects, they all have the same risk, they all have one road connecting the beach to the rest of the Netherlands, etc. They are all dependent on nice weather, etc. So we are already scaling up there. On the other hand, let's say the predictions for number of people expected and the predictions of number of cars expected in the parking garages can be used also on other cities and other locations. The thing is, the risk levels change, right? So the risk levels which we created here were those risk level forecasts were really based on, let's say, the dynamics of a beach area. But in the end, the basis of those risk levels was a forecast measuring, okay, how many people can we expect? So, and these two separate forecasters can be used in other locations, for instance, inner cities or large events, etc., etc. So not everything is easily copy pastable, more or less, but small parts are. But still, then you always need to look at the local context. You always need to understand what the effect of a lot of people in the situation is, giving the surroundings.
Yeah, and I think also looking at the purpose for which people are going, for example, to inner cities. Is it for shopping? Do they live there? Are there companies? It can also be a mixture. If you look at Scheveningen and other beach areas, then you know that the main reason for people going there is during events or during the warm weather. But 5 degrees windy weather in the inner city of The Hague is a completely different situation that really needs more research to be able to also apply it there. But I think the principles of using AI, using the different data sources, I think that's what you meant, are the same. But learning more about the context is important.
Yeah. Yeah, thank you also, Sasha, for this addition. Actually, we have been asked about something related to the municipality aspects, let's say, so from the point of view of policy. So I assume that implementing this kind of improvement means that the municipal teams should be effectively trained, or they should change some decision support system or something like that. How is hard or how is difficult? yeah, actually, what are the critical aspects on this?
Well, so you are right. So actually, we did a good job in the technical part. So we built predictions. I mean, it's always step one, which of this is always the availability of data. Now, in this case, we were lucky that we already had a project, that we have a lot of historical data, because if you have a lot of historical data, it means you can build proper forecasts. And still then, there's a lot of challenges from a technical perspective. But I think the biggest challenge lies with, let's say, data-driven decision making, right? So at this point at Scheveningen, they have a very good organization. So they're already doing it very properly, a very good organization based on different roles, different functions, and based on a lot of experience. And of course, a lot of historical reporting. And they currently have their way of working also without the emeralds, right? And that still works pretty good. So on the other hand, they see the benefit of more data-driven decision making, but the biggest challenge lies with, okay, how can they implement this data-driven process, right? This measuring numbers and then also knowing what to do with it. Yeah, that is a pretty difficult part, and that's also something we are really learning at this point in time, because now we provide them with data, and hopefully after the summer we will sit down and say, okay, how can we implement this? How can we embed this in your processes? So at this point, I cannot completely answer it because we're still learning that.
Yeah, of course. So it's an ongoing process. Let's say.
Exactly.
We'll see. Sasha, do we want to comment or add something?
No, I think it's correct. I think we, from a project perspective, are always looking to develop new things. We're convinced that things are an improvement, but the process to really get it into the systems, but also in the minds of people, into the organization, it takes more time. Yeah. But these types of projects do help to show the value.
Yeah, I agree. Yeah, and thank you. Yes, I actually have the last question. I don't know if we have time. Probably, yes, we have 3. Yeah, we have 5 minutes. So we can use for this this one, which is actually every time comes to. I mean, in a different form, it becomes a question, because it's the concern that always have been raised between the public safety and the privacy concern when collecting data or, you know, analyzing crowd data, these kind of things. So how you manage to balance this?
I mean, in the Netherlands, we're pretty strict. We're pretty experienced here. Therefore, a lot of the data which might be there, we could not share it. But it's very important to say is that everything is privacy proof. So it's privacy by design, and that it has been the case already a couple of years ago. So we do not track people. We do not know who the people are. We can never see which people are there. We only estimate a total number of people in a different area, and we do not know if it's person A or person B, and we can also not measure it. We do not have video camera feedage. We do not see people. We only get numbers, and we only get aggregated numbers, and we put that into colors, right? So it's privacy by design. What's the discussion, or at least the topics which we cover, are from an ethical perspective. So actually what you're saying, it's an ethical question. Okay, we use mobility data to predict how crowded it will be, and we use this data to, let's say, influence people, to manage people, to influence them. And in the end, of course, they are, it has to do with all of them safety, but on the other hand, you are influencing them. You're saying, no, you cannot drive to A, you need to drive to B. You make decisions for people. And what we do to cover this is what they call ethical table. So we organize multiple ethical tables. An ethical table is actually sitting down at a table, physically sitting down at the table with all stakeholders involved. The police, the local people, representative of the civilians, municipalities, technical providers, and then in the Netherlands, there's a sort of structured way. It's called ethical table perspective. I don't know, but it's a structural way in which, on the one hand, you talk about, okay, which values do we think are important? What is technology, and how do we solve this, right? So, and it's a sort of a structured way in which you at least discuss the values and also determine if the balance between, let's say, the ethical part and the safety part is right. And what we notice is that, I mean, people understand that if it gets too crowded, it can be dangerous. And they also understand that having proper data can help you. So if you talk about it, in the end, it's always not so excited as you would expect it. But you need to involve people. You need to ask them, what do you think of this? We are doing this, what do you think of this? And how can we solve this? And which values should we use? And in the end, if you take them on board in this whole process, and eventually we have multiple ethical reports written, in the end, everybody is more or less positive, because everybody understands, everybody wants a safe beach. That's it. The thing is, yeah, you need to involve everybody, and that's what we organized. Yeah, that's how we deal with that. Simply talk to each other about
yeah, understandable. Yes,
about the ethical parts. It should not be a secret. That's it, right? It should be open and transparent, and you should also share your challenges.
Let's say the key is transparency.
That's it. And
That's
participation.
it.
Yeah.
Yeah, Sasha, do you want to add something?
No, not that much. The only thing, like Jeroen explained, the ethical tables are, I think, essential, because you can also talk to people from the different types of stakeholders. So you can invite people also, because you have apartments near the beach, you have shop owners, you have the police, you have different levels, policy, but also operators on in Scheveningen. So you can invite a variety of these different people. But still, I have to say that although we know that we don't record people's images and never are going to see that, people on the street can be a bit scared about the fact that there's a camera hanging or some other type of sensor. And you don't explain for last year, someone simply clicked off some of the sensors because they didn't know what it was for. So on the one hand, you can organize a lot of things, but you are never able to reach everybody. And yeah, there will always be people that are in some way scared about it. So I think you should also use things like a QR code near your sensor so people can look up what it's for. But even then, the doubts will always be there.
Yeah, it's very interesting. I mean, I want to say that to the audience today that this project is very interesting, isn't it? So please follow us, because we are we are closing we are close to the end of the project, but we have the very intensive 6 months ahead of us, and we are going ahead with our path, which is full of interesting aspects. And these 3 use cases today. This use case closes the section of the 3 use cases and the 3 webinars. So you will have at your disposal very soon the recording of the 3 webinars, and follow us and subscribe to the newsletter, and stay tuned for the next initiatives that we have in the project. I don't know if Konstantinos, the project coordinator, wants to add something. We are closing the webinar.
Yes. Thank you for the presentation, Jeroen and Sasa. Jeroen, that was a very interesting, very interesting demo, and the whole explanation is really important because people, may not conceive the term of risk with the same aspect every time. So you described very well why this use case is important for the whole Emirates project. The one thing that I would say would like to emphasize more is on the impact of the whole Emeralds project, and that's why very soon we expect to deliver the final report that would demonstrate both the technical aspect of Emeralds as well as the whole use case validation. So that's all for me.
Thank you very
Of
much.
course, do not willing to mention that several technical services of the Emeralds project have been selected for the innovation platform radar that really showcase the great impact of the project.
Exactly, and thank you, Konstantinos, for this last note. And yeah, thank you very much for your participation today to the webinar. Thank you for your time to all the panelists. See you soon and have a good day.
See you next week.
Bye-bye.
Yeah.
Bye bye.
Bye.
Jeroen, ben jij nog even
Bye-bye.
belbaar?